All right, now we're ready to start the second half of this unit. So in the first half, we were focused on multiplying our polynomials together, kind of using that double distributive property, multiplying all those terms together and getting a larger, more complicated polynomial. Now we're going to work on going backwards. So instead of multiplying it out, we're actually going to split it back up into pieces, because that's going to help us in how we are trying to solve these equations as we get farther into the unit. We're going to kind of break them into parts that we do know how to solve in order to help us get to our solution. So some vocabulary to start with. The GCF for a polynomial is a combination of all of the factors, numbers and variables, that all terms have in common. So we're looking for what can they all be divided by. The steps we're going to use are pretty straightforward. First, we're going to find the GCF of all of the terms. What common factors do each of those terms all have in common? Then we're going to divide the GCF out of each of those terms, and then we're going to write the factored form, so kind of the pulled apart form of our polynomial. All right. So let's see that in action. So we start by finding our GCF. So 24x and 48y, what do they both have in common? Well, they have different variables, so they don't have that in common, but 24 and 48 both have a common factor of 24. Remember, we want to go as big as we can, because they also have 2 and 3 and 4 and 6 and 8 and all those, but we want to go as big as we can, the greatest factor they have in common. So what we're going to do is we're going to pull apart each of those terms using that 24. So 24x is really 24 times x. And 48y is really 24 times 2y. So we're going to split it apart using that greatest common factor. That GCF gets pulled out front, because I could take it from both of them, and then I'm left with x plus 2y. So basically, it's kind of like undistributing that 24. We're pulling that back out of the problem. So B, 2x to the fourth minus 16. Well, they don't have any variables in common, but they both can be divided by 2. So that's my greatest common factor. So 2x to the fourth is really 2 times x to the fourth, and 16 is really 2 times negative 8. Notice how that negative goes with 8, since the 2 doesn't have that negative in common in both terms. The greatest common factor is what's factored out front, and then I'm left with x to the fourth minus 8. Okay. Next one, starting to get a little more complicated, 9x squared minus 3x. So my greatest common factor, in this case they both have a 3 in common, but they also have an x in common. So I'm going to pull an x out of each of those terms as well. So I can pull out the 3x from 9x squared. That leaves me with 3 and an x, because 3 times 3 is 9, and x times x is x squared. Then I can pull a 3x out of the last term, but I'm left with a negative 1. So each term could be divided by that 3x. That 3x slides out front, and then the 3x minus 1 remains on the inside. Okay? As you're doing this, if instead of taking the negative with the 1, if you want to leave it as a subtraction instead, that's totally fine. Then that subtraction just slides down into our answer. They both get us the same answer, it's just kind of the notation of how you want to show it. All right, so let's try a couple more. They're starting to get a little bit more complicated. So start by looking at what do they both have in common. Well, they can both be divided by 4, and they both have at least one x in them. So I'm going to break them apart using that 4x. So 16x squared is really 4x times 4x. And then 4x times 3 gives me 12x. So my factored form, pulling that 4x out front, gives me 4x minus 3 left over. So I took that bigger, more complicated polynomial and broke it into two pieces, a 4x and a 4x minus 3. Next one, my GCF, what do they all have in common? Well, in this case, there's no coefficient, no number that goes in all of them, but they do all have a q in common. So I'm going to factor a q out of each of those terms. So this becomes q times q to the third minus q times 18q squared. So think of it as I'm kind of subtracting away. I'm taking away one of the q's, so it's just going down by 1. And then I've got q times 22. So that q can get factored out front, and I'm left with q squared minus 18, or sorry, q cubed minus 18q squared plus 22. All right, next one, getting bigger. So what do they all have in common? Well, they all have a 4, and they all have at least one x. So I'm going to break each of them apart. So 4x to the fourth is really 4x times x cubed, because I took the 4, and I took one of the x's. And then I have 4x times 4x squared, because remember, I want my exponents to combine to give me what I started with. Here I'd have 4 times, 2x, I messed that one up. So I'm going to divide out my 4x, and I'm left with 2x, because that would give me 8x squared, and then 4x times 3. So that common factor of 4x is pulled out front, because I could take it from all of them, and then the leftovers, x cubed minus 4x squared plus 2x plus 3 remains inside. All right, last two, and these are definitely getting more complicated, a little bigger. So first, start by looking at what do they have in common. What can I take out of all of them? Well, they can all be divided by 3, and I can take an x out of each of them. So this becomes 3x times 7x cubed, because I want it to be a total of 4x's. And then 3x times just x squared, because I took the 3 and I took one of the x's. And then 3x times 4x to give me 12x. And then 3x times 5. So I've got that common factor of 3x. And then I've got 7x cubed minus x squared minus 4x plus 5 left over. I still have a fairly complicated expression, but at least I was able to pull out some of the terms and simplified a little bit. I brought the degree of it down a little bit. All right, last one. This one's going to be big. Okay, there's a lot to manage in this one. So looking at my numbers, 9, 6, and 12, well, they can all be divided by 3. And then I've got x to the 6th, x to the 3rd, x to the 2nd. So I can take out 2 x's from all of them. And then looking at the y's, I have y to the 3rd, y to the 5th, y to the 8th. So they all have at least 3 y's that I can take from them. So for each one of them, I'm going to break it down and pull out, I'm going to factor out that 3x squared y cubed. Well, for my first one, the 9 breaks into a 3 and a 3. For the x's, I took away 2, so I'm left with 4 of them. And then for my y's, I took all 3 y's, so I'm just left with 3x to the 4th. For the next one, 6 becomes 3 and a 2. X to the 3rd is x squared and just x. Y to the 5th is y to the 3rd and y to the 2nd. So I'm kind of seeing what's left over after I've pulled out that common factor. And then last one, 3x squared y cubed. Well, 12 is 3 times 4. X squared is just x squared, so there's no x's left inside because I took them all. And then y to the 8th is really y to the 3rd and y to the 5th. So there's 5 y's left over. So my factored form is 3x squared y cubed. And then inside I have 3x to the 4th plus 2xy squared plus 4y to the 5th. Okay? That one got big, and that's okay, but that's what we're looking for. Pulling out any of those common factors and then seeing what do I have remaining.